guys, and welcome to Sifasok Academy the Intellects on YouTube. In this channel, we are out to help the advanced level science students to attain their academic excellence and their academic goals by providing them with the correct and the time-saving approach to all GCE questions as proposed by the GCE board. So in this video, we are looking at advanced level science MOCK 2024 paper 2 mathematics, pure maths of course. So if you are new in this channel, I'll invite you to subscribe to the channel and activate the notification bell to not miss any of our videos uploaded. And now, just as a reminder, the phone numbers that is on screen, you can text us on WhatsApp to just give us the question that you want us to do a video on, that is a particular GC or a mock question of your choice, or you can also email us using our or via our email address that you see on screen. So the question is question 1. We are solving the whole question, both polynomial and linearization of the equation. Good. So they said, given that the zero, that's 1 and 1, given that the zeros of the polynomial that are a and b and a plus b, determine the values of a and b. Good. So we have to recall something here, that the zeros of a polynomial is also called the roots or the factors of that polynomial. I take for example, if you have an equation, for example, you have that is a quadratic. Let's take it easier. A quadratic equation of the form x squared minus 3x plus 2 is equal to 0. We are saying that to factorize a quadratic equation, we are going to be left with x minus 1 times x minus 2. Okay, of which x will be equals to 1 and x is equals to 2. X equals to 1, x equals to 2 are the roots of the quadratic equation. So to form back the quadratic equation, what we go directly step up, we have x minus 1 times x minus 2 is equals to 0 to form back the quadratic equation. So here is the same idea. We are forming the polynomial with that particular factors there. So we have what, x minus a times x minus b times x minus a plus b is equals to 0. Good. So from there now we can now expand to get x squared minus ax plus b, that is minus bx plus ab into x. We open up the bracket with negative, minus a minus b equals to 0. Expanding the whole thing, we'll get x cubed minus ax squared minus bx squared minus ax squared plus a squared x plus abx minus 2bx squared plus, well, it continues, then is equals to 0. Good. So from there, if that is, you can pause the video and then you multiply it properly to keep on track. So rearranging the equation, I'll get x cubed minus 2a plus 2b into x squared, then plus a squared plus b squared plus 3ab times x minus x minus a squared b minus ab squared equals to 0. Okay, so that is it. Now from there, we are now required to do what? Equate the coefficients, because that is the idea. We equate the coefficients of this polynomial to the equation of this polynomial here. Okay, because it said they are the zeros. So from there, we'll get what? We get the coefficients of it, that is, we'll compare it with our polynomial here, and from there, equating the coefficients, we equate the coefficients of x squared, because coefficients of x cubed and x cubed here is 1 1, so it's okay. Equals to coefficient of x squared, we have 2a plus 2b. Here we have 2a plus 2b is equals to 2. And now I'm not equating the negative because negative will cancel. Then you imply that a plus b is equals to 1. I call this one equation 1. Okay. Now the next, I don't want to equate the coefficient of x and x because I'm seeing here that it will give me two values of which I don't want that. Remember that we are giving to you the time-saving approach. So I equate the constant terms. Because in the constant term, I'm going to get what? A squared b plus ab squared is equals to 2, which implies that I can factor out the b, and cancelling the b out, I will get a squared plus ab is equals to 2, and I call this one equation 2. Okay, from there, these are two simultaneous equations, or this is a simultaneous equation. Do we say simultaneous equation? But let's say it's a simultaneous equation with two unknowns. Simultaneous equation with two unknowns, which is very well possible to find. So we'll solve by the substitution method. from equation 1, we see that b is equals to 1 minus a. I call this equation 3, and then I replace equation 3, or I substitute equation 3 in equation 2. I will get here a squared plus a into what? 1 minus a, because b is 1 minus a, don't forget, is equals to 2, which implies that a squared plus a minus a squared is equals to 2. A squared minus a is 0. Then we'll be left with a equals to 2. Then from there, I replace the value of a in equation 3, so that will be more easier for me. We imply that b is equals to negative 1, because 1 minus 2 is negative 1. So that's all for the first part of the question. The second part of the question, they said we should linearize the equation. So to linearize the equation, the first thing that we have to do, because here I'm seeing a power already, so I take the link on both sides. So taking link on both sides, I'll get link y is equals to link a into x squared into x plus 2 all to the power n. So I recall a property, or two properties, that link ab is equals to link a plus link b, and link a to the power n is equals to a is equals to n link a. This is Chapeau law. Then from there, now I will see that what I can translate it to this my expression here, or to this my equation, to link y equals to link a. I separate it together, plus link x plus 2 all to the power n. I apply this law here to get what? Link y is equals to n link x plus 1. When I rearrange it directly, x plus 2 instead, plus link a. So I compare it with y equals to ms plus c, which is the general equation of the line. I will see that what the gradient, which is what I've asked us to solve, gradient m is equals to n, and intercept c is equals to link a. The intercept that we're talking about here is the y-intercept, because to find the x-intercept, y needs to be 0. But if we substitute y equals to 0 here, the link of 0 does not exist, so the x-intercept does not also exist here. So we have the y-intercept, which is x equals to link a, and the gradient n, which was what was asked us, which was what was asked to find. So guys, we have come to the end of this video, and if the video was interesting to you, I'll invite you to like the video, subscribe to the channel, and turn on the notification bell to not miss any of the video uploaded. And if the video is interesting more, you can forward the video to your friends for them to also attain academic excellence. And not forgetting that in science, consistency is the key.